This is Dr. Brahmayya, Associate Professor, Department of SNH, MLR Institute of Technology, Hyderabad. Today, I am going to talk about breakpoint of chlorination. So, we are going to talk about the breakpoint of chlorination. So, in the overview, we are going to discuss the topics like chlorination, breakpoint of the chlorination, advantages and disadvantages of the chlorination, and dechlorination. So, what is chlorination? We know that halogen is a most toxic chlorine gas for the medical field. So, as a halogen, chlorine is a highly efficient disinfectant and is added to public water supplies. Why? Because of water chlorination is the process of the adding chlorine or chlorine compounds such as sodium hypochlorite to water. Sodium hypochlorite to the water. This method is used to eliminate or to kill bacteria, virus, and other microbes in the water. So, in particular, chlorination is used to prevent the spread of the waterborne diseases such as cholera, dysentery, and typhoid. So, these are the actually diseases we always get due to the presence of many organisms like bacteria, virus, and other microbes in the water. So, we have to kill at any cost all these things with some chemical methods like chlorination method. This is the chlorination method to disinfect the water. Chlorine and water will become hypochlorous acid. This is a hypochlorous acid which can kill bacteria. So, this is the actually while adding the Cl2 to the H2O, we will get HOCl like this. Then HCl is a byproduct. This is a vice versa reaction. Both sides it will happen to and fro reaction. So, when you add the H2O chlorine to the H2O, hypochlorous acid will become like H plus and OCl minus ions. So, these will form these ions. HOCl forms H plus OCl minus ions which are causing the disinfect activity in the water. How? And it is forming this H plus and OCl minus, how these are forming and how they are killing the bacteria, with which concentration, at what concentration of the chlorine passed to the water. So, generally, if you take the water, a pure water, if you add a chlorine, the chlorine curve will be like linear straight line. So, chlorine added, the dose of the chlorine is here in mg per liter, and the chlorine residual mg per liter is here. So, when you add it without any kind of impurities of water, the water which is having a very pure water, it does not have any kind of inorganic metals or inorganic compounds or organic compounds or living organisms, then your graph is like this. So, how much you are adding to the chlorine, that much of concentration it will be available as a free available residual chlorine compound in the water. But whereas if you go to some groundwater, there might be many inorganic compounds and organic compounds, organic matters. We have to kill that living organisms and we have to purify that water without any inorganic minerals. So, for that, So when we are taking the groundwater or surface water, calculated amount of the chlorine must be added to the water, because chlorine, after reacting with bacteria and organic impurities or ammonia, remains in water as a residual chlorine. So while we are adding the chlorine to the water, we will have a residual chlorine after reacting with bacteria, organic impurities, and ammonia, and remains in the water. So which gives a bad taste, odor, and toxic to the human beings. How the bacteria is killed by the chlorine, same like the toxicity of the chlorine will be affected the human beings if it is exceeded in the water. So it should be measured at certain point. We should stop the addition of the chlorine to the groundwater. If it's very pure water, there is no impurities, there is no any kind of living organisms, infectious disease causing organisms, then we don't need to add the chlorine, no issue. But at the same time, when the groundwater, when we are taking, we have to take chlorine addition to the water, because to reduce the inorganic compounds, organic compounds, and ammonia. So when certain amount of the chlorine is added to the water, it leads to the formation of the chloroorganic compounds and chloramines. It leads to the chloroorganic compounds and chloramines. So Cl2, H2O, as we discussed earlier, HOCl, hypochlorous acid, and HCl. And further, we will check how the chloramines will be formed, how the chloramines are formed in the chlorination. So the point at which free residual chlorine begins to appear is known as breakpoint chlorination. The point at which the free residual chlorine begins to appear is known as a breakpoint, which should be stopped over to. The amount of the chlorine required to kill bacteria and to remove the organic matter is called breakpoint of the chlorination. What is the breakpoint of the chlorination? Is it should be stopped. The addition of the chlorine is stopped at certain point when it is adequate to kill the bacteria and to remove the organic matters and inorganic compounds. So this is the breakpoint of the chlorination. Once these all are removed, then we have to stop the chlorine addition. Otherwise, this additional chlorine gives the bad taste for the water, and it is also toxic to the human beings. As in, the breakpoint determines whether the chlorine is further added or not. This is the condition what we have to know. See here, initially chlorine dose is adding here in ppms. Chlorine residual, how much it is present in the water, we have to check it, and how it is enough, and at what point it is enough, we have to check it out. That is the main target of our breakpoint of the chlorination graph. This is a graph. Actually, initially iron, manganese, nitrate, these are the compounds. These will be oxidized. These will be reduced. These are the oxidizing agents. These will be reduced to some other chemicals. So they will be come down. They will be come down at this bottom point. And then secondly, formation of the chloramines. Formation of the chloramines. Non-organic materials and organic materials, ammonia. These are the compounds. Trihalomethane, monochloroamine. These will be formed. So with the ammonia, the chlorine can mix together. It will form chloramines. Chloramines. What is that? Monochloramine, dichloramine, and trichloramines. So this is the ratio 5:1 Cl2 NH3 and N. Finally N2 will be formed. Once it is saturated, the ammonia is saturated, ammonia is becoming a completely NCl3. Then finally the addition of the Cl2 gives N2 gas. So next, destruction of the chloramines. So the destruction of the chloramines must be happened because these chloramines also will kill the bacteria, but these will be also toxic to the human beings. So that we have to destruct the chloramines by addition of the excess chlorine. So it is a 5:1 ratio. Chlorine 5, ammonia 1, and finally N2 will be formed. So it is a combined chlorine. It is a combined chlorine. It is a combined chlorine at stage 3. In the breakpoint, fourth one, building of free chlorine residual and combined chlorine. Building of free chlorine residual and combined chlorine. So here we are availing that chlorine, addition of the chlorine gives you free available residual with the linear graph. As we discussed in the previous graph, it's a linear graph. When the inorganic materials, organic materials, and the chloramines are destructed, and the inorganic materials came down after reduction in the chlorine, these will become under the bottom line. At specific point, we will see the free available residual chlorine. It implies that the inorganic salts came down in the water, and the living organisms also died and be killed, and then destruction of the chloramines. This all will be happened. Then only the chlorine linear graph will be like this. It implies that free available chlorine is residual is available. So it implies that we have to stop at somewhere in the breakpoint group. What is the breakpoint chlorination now? So removal of all the inorganic salts, removal of the ammonia or living organisms to kill the living organisms, and the water is clear. From that one onwards, the chlorine will be started to increase. The residual will be started to increase. So we have to notice this point. This is the most important, significant point in the breakpoint of the chlorination graph. From the graph, it is clear that in stage 1, 8 grams of chlorine added oxidizes reducing impurities like of the water, like magnesium salt, calcium salts, iron salts. These will be reduced. In stage 2, V grams of chlorine added forms chloramines with the nitrogen compounds present in the water. In the second step of the graph, stage 2, V grams of the chlorine added, which forms chloramines. The chlorine at this stage is present as the combined chlorine. The chlorine at this stage is present as the combined chlorine. So this is the Cl2, H2O, hypochlorous acid, and HCl. This is the basic reaction in the addition of the chlorine to the water. Two ammonia molecules will react with two hypochlorous acid molecules, which gives rise to two NH2Cl molecules and 2H2O. Ammonia plus hypochlorous acid yields monochloramine. This is the monochloramine. One chlorine is added to the ammonia. This is the monochloramine. Next, this is the dichloramine. Here, again the same reaction will be happen with this 2NH2Cl plus HOCl will give you 2NHCl2. This is a dichloramine. and then this dichloramine again reacts with HOCl, hypochlorous acid, and it will form NCl3, 3H2O. These are the products. So it's a trichloramine. Likewise, the reactions will be happen with the chlorine in addition to the water. While addition of the chlorine, ammonia will become monochloramine, dichloramine, and trichloramine. After reducing the impurities, inorganic impurities will be reduced, then chlorine is started to react with ammonia in this series. So here the actually ammonia, monochloramine, dichloramine, trichloramine. Use the nitrogen atom. This is the nitrogen atom. This is the formation of the chloramines. These also will kill the bacteria or living organisms which are not good for the human health. So any fungus or virus, bacteria, they will be disinfection will be happen by addition of this chlorine, and also along with chlorine, while these products are forming, these products chloramines will also kill the bacteria. In stage 3, 6 grams of chlorine added causes destruction of the chloramines. So now we are adding the some little extent of the chlorine. The trichloramine on the addition of the chlorine is eliminated as a nitrogen gas. So while we are still adding the after trichloramine, we are adding the chlorine, then nitrogen will be released finally. The concentration of the chlorine at this point dips. The concentration of the chlorine at this point dips means the free available residual chlorine is available in the particular water sample. The addition of the chlorine to water at this dip or break is called break point of the chlorination. So this is the break point of the chlorination. Stage 4, last slot, d grams of the chlorine added is seen as a residual chlorine. At this point, the chlorine acts as a disinfectant and kills the microorganisms. So here onwards, in the 4th stage, finally, the addition of the chlorine will kill the microorganisms. The advantage of the breakpoint of the chlorination. If you look into the advantage of the breakpoint of the chlorination, complete destruction of the pathogens, complete oxidation of the organic compounds, ammonia, and other reducing impurities. Likewise, MgSO4, RCA, SO4, or SO4. These are the compounds. It will be reduced. And the chlorination is also prevents the weed growth, prevents the growth of the microbes. So this is the good advantage of the chlorination. Here is a note: HOCl, which is formed by the dissolution of the chloramines in water, reacts with microorganisms and inactivates the enzymes present in it, so that the microorganisms are destroyed. So this is the key point which can kill the bacteria. This is a major key point to kill the bacteria. This is the hypochlorous acid. So dechlorination. If, for suppose, it is exceeded, the chlorine is exceeded in our sample water, then we have to remove that excess chlorine. So for that, there is a chemical process. If excess of the chlorine is added, then it can be dechlorinated by passing it through activated carbon or by adding SO2, Na2, SO3. So any activated carbon, charcoal, something like that, any biomass derived carbon. So the activated carbon will be added or by adding SO2, Na2, CO3. So in general, sulfur dioxide reacts with chlorine and water. It forms H2SO4 and 2HCl. These are the very strong acids. So Na2CO3 plus Cl2 H2O gives rise to sodium sulfate and HCl. So likewise, we can remove the chlorine. Chlorine is removed. This is the chemical process. Or by adding also activated carbon also, we can remove the chlorine in the given water sample. If exceeded chlorine is added, then we have to remove it. This is the key points of this topic. In summary, we concluded that the presentation covers the chlorination and breakpoint of the chlorination, how the inorganic and organic compounds can be consumed chlorine, and then after the breakpoint, how the chlorine can become strong disinfectant to kill bacteria or pathogens was explained. This is the significant points of this particular presentation or topic. This is the brief discussion of the breakpoint of the chlorination. Thank you.